Hello and welcome to your first lesson of Unit 2 on matter and changes. Today we're going to talk about the properties of matter and what it takes to have a chemical change happen. So, reviewing properties of matter, we're going to go through extensive versus intensive properties. So, an extensive property is a property that depends on the amount of matter in a sample. Mass is a measure of amount. Volume is a measurement of space occupied. So extensive properties, the amount of it matters. So this could also be length. And so we have to also talk about intensive. So the reason why intensive is so important is these are used to identify what we're working with. So intensive properties depend on the type of matter, not the amount. So this is how they differ. So things that would be examples would be hardness, the color, it doesn't matter how much you have, the density, it does not matter how much you have, but these are things that can help identify what type of matter we're looking at. So then we get to a substance. And a substance is just a name for matter that has a uniform and definite composition. We're going to get more into this type of discussion when we get into our next unit, talking about types of matter and solutions, if they're homogeneous or heterogeneous, so we'll get there. But the key with substances is that they have to have identical intensive properties. Which makes sense. If they're uniform, every part of it better be the same if we use that to identify it. And so a physical property, this generally is described as a quality or condition that we can observe without, so that's the key, without changing that substance composition. So for example, if you rip a piece of paper in half, both halves are still paper, you're not changing the composition, just its qualities or conditions, how it looks. So as a quick review of states of matter, our three states we look at are solid, liquid, and gas. So below I have some pictures here depicting those three states of matter. So solid, what we know about them is that they are definite in shape, meaning their shape is not going to change. So you could think of a desk. It's not going to change shape no matter if you tip it upside down or not. And the volume's not going to change. So definite shape and volume. Liquid. Now, if I have a cup of coffee or a glass of water, if I tip my glass, that liquid is going to change its shape. So this is what we call indefinite shape. But unfortunately, even if I wish it, my cup of coffee is not going to magically grow, so it does still have definite volume, meaning that will not change. Then we have gas, what we know to be our most full of energy and free moving. So what's awesome about gas, no matter what container you put it into, it will change to that shape and volume. So we say indefinite shape and volume. All right, so moving on to chemical properties. So for it to be a chemical property, the key here is that we're undergoing a chemical change. And so in order for something to be considered a chemical change, you need to change the composition. So a common misconception is if you boil water, that's a chemical change. But that's not true. When you boil water, you're just turning it from its liquid state to its gas state. So changing in states of matter is not a chemical change because H2O is still H2O, even when it's a liquid or a gas. Changing the composition means creating a whole different substance. And so in order for a chemical reaction to occur, just one or more substances has to change into one or more new substances. And so to give ourselves some terminology here with a chemical reaction, we have reactants. These are what do the reacting. So reactants, they are present at the start of reaction. Products are what are produced in the reaction. And so we have some clues that tell us, how do we know? I think this is telling me a chemical change occurred. So these clues include if you see a change in color. So likely, if you see a change of color, a chemical change occurred. These are not guarantees that it occurred. For example, the next one is change in temperature. We just discussed that boiling water is not a chemical change. That is a change in temperature. But sometimes why this can be a chemical change is if you add two chemicals together and then the solution heats up without us using any sort of heating element, that's what makes a chemical change, is that the reaction itself is producing the heat. We're not adding the heat to the reaction. The next would be a production of a gas. So if you see bubbles in an experiment, that means gas is formed. And then lastly, the formation of a precipitate. And so you may think of rain, we call it precipitation, but in chemistry, this is specifically a solid that forms or settles out of a liquid. So let's say we take one liquid, we mix it with another, and when those two mix, all of a sudden, this solid starts forming. That is what we would call the precipitate. Now, the one thing I do want to mention here too is that we have to remember a special law of ours. And so during any chemical reaction, the mass of the products is always equal to the mass of the reactants. So it's saying the mass of all the stuff you put in better be the mass of everything you get out. And so this demonstrates the law of conservation. Which is, you can't create or destroy matter. And so there's a way we can talk about this just using some simple math. And let's say we have a reaction that starts with 30 grams, so I'm going to abbreviate that as G, of hydrogen. You make 45 grams of H2O, so I'm just putting them under their respective formulas here. How many grams of O2 is reacted? I'm going to make that my X. That's what we're going to solve for. So anytime you see a plus sign in the reaction, you're going to put one in your equation. Anytime you see an arrow, you're going to put an equal sign. So now all we're left with is going to be solving for this X. So how do we get X alone? We are going to subtract 30 grams from each side. And what we end up getting is that X is equal to 15 grams.